Okay, so far we've made one big assumption through this whole thing, and that is, so far we've assumed that all of our variables represent positive real numbers. And that's because when we allow other numbers into this mix, this stuff gets screwy. We're not going to define rational exponents for complex numbers at all, but we will consider negative real numbers. What are we going to do with the negative real numbers? Well, remember, we defined x to the p over q to be the qth root of x to the pth power. When is this defined for x negative? This is defined for negative values of x if q is odd. So we say, this has a weird consequence. As I hope we're all aware, 2/3 is equal to 4/6. But 3 is odd, 6 is even. So x to the 2/3 is defined for x negative, x to the 4/6 is not. When we're taking rational powers of negative numbers, there's something a little fishy going on. We're still going to do it, but we should be a little bit aware of the weirdness. A lot of the manipulations we do get really complicated when x is allowed to be negative. So most of the time, we're going to say x has to be positive. It should also be noted that the 6th root of x to the 4th is perfectly well defined for negative x. Why? Because we take the 4th power of x and always get a positive answer. And we can take the 6th root of that. But in some cases, this gets even stranger. For example, compare -1 to the 1/3, which is just the cube root of -1, which is just -1, to what we would get if we take -1, square it, and then take the 6th root. -1 squared is just 1. Do you see what happened here? This is what -1 to the 2/6 would have to be if it was defined. Moral of the story? For x negative, we're best off just always keeping our exponents in lowest terms. Anything that involves writing an exponent not in lowest terms, probably best to stick to doing for positive values of the variable. With all that said, we can still compute some of these negative rational powers. So let's say we want to compute -32 to the 3/5. By definition, that's going to be just the 5th root of -32 to the 3rd. Let's take some 5ths powers of negative things. -1 to the 5th is -1. -2 to the 5th will be -2, 4, 8, 16, 32. There we go. So we'll have -2 to the 3rd, and that'll be -2, 4, 8. So we get -8. It's important also to distinguish a negative number versus a negative exponent. Putting this together with what you saw in the last video, try to compute -1/125 to the -2/3 power. I'm going to give you the hint that 125 is 5 cubed. Pause the video and try this now. All right, so because this is a fraction already, I'm going to use the -1 power first. But watch. This -1 power is just going to take the reciprocal. 1 over n to the -1 power is just n, even if n is a negative number. So this is going to be just -125. to the 2/3. I know that 125 is 5 to the 3rd, so negative 5 to the 3rd will be negative 125. Odd powers keep the sign. So we'll have cube root negative 125 to the 2nd power. Cube root negative 125 is negative 5. Negative 5 squared then is negative 5 times negative 5 is positive 25. Notice why we lost the negative sign. We multiplied a negative by another negative and got a positive result.